The name of the unit is gaseous state. You all know matter exists in three physical states in Earth. They are solid, liquid and gas. In solids, the particles are most orderly packed. There is a long range of order. They have definite shape and definite volume. They are incompressible. In liquids, the particles are not so orderly packed. There is a less range of order. They have definite volume, but they do not have definite shape. They assume the shape of the containing vessel. They are compressible only through a small extent. In gases, the particles are loosely packed. There is least range of order. They do not have definite shape and definite volume. They assume the shape and volume of the containing vessel. They are compressible to a large extent. The measurable properties of gases are volume V, pressure P, number of moles N, and the absolute scale of temperature T. Then let us study the gas laws. Boyle's law, Charles' law, and Avogadro's law. What is Boyle's law? Boyle's law states that volume of a fixed mass of gas is inversely proportional to pressure at constant temperature. V directly proportional to 1 by P at constant T. That is, V is equal to K into 1 by P. PV is equal to K at constant temperature. This is the expression for Boyle's law. Consider P1 and V1 are the initial and P2, V2 are the final values of pressure and volume. Then P1, V1 is equal to K and P2, V2 is equal to K. So, according to Boyle's law, P1, V1 is equal to P2, V2. Then second law is Charles' law. Charles' law states that volume of a fixed mass of gas is directly proportional to absolute temperature at a constant pressure. V directly proportional to T at constant P. V is equal to K into T. V by T is equal to K. This is the expression for Charles' law. Consider V1 and T1 and V2 and T2 are the volume and temperature of initial and final state. Then V1 divided by T1 is equal to K. V2 divided by T2 is equal to K. That is, V1 divided by T1 is equal to V2 divided by T2. Combining these two laws, that is Boyle's law and Charles' law, we get P directly proportional to 1 by P at a constant T according to Boyle's law. Then V directly proportional to T at a constant P according to Charles' law. Combining V directly proportional to 1 by P into T. V directly proportional to T by P. V is equal to K into T by P. PV divided by T is equal to K. Consider P1, V1, T1 are the initial and P2, V2, T2 are the final pressure, volume and temperature. Then P1, V1 divided by T1 is equal to K. P2, V2 divided by T2 is equal to K. That is, P1, V1 divided by T1 is equal to P2, V2 divided by T2. Then third law is Avogadro's law. What is Avogadro's law? Avogadro's law states that equal volume of gases under the same condition of temperature and pressure contain same number of molecules. That is, V directly proportional to En at a constant T and P. Then we can derive the ideal gas equation. Combining Charles' law, Boyle's law, Avogadro's law, we derive our ideal gas equation. According to Boyle's law, V directly proportional to 1 by P at a constant T. According to Charles' law, V directly proportional to T at constant pressure. According to Avogadro's law, P directly proportional to N at constant T and P. Combining these laws, V directly proportional to 1 by P into T into N. V directly proportional to N T divided by P. PV is equal to nRT. This is called ideal gas equation. Another expression for ideal gas equation is given below. P is equal to rho into RT divided by M.
This equation is helpful for doing the problems.
Next one is absolute scale of temperature. What is Charles' law? According to Charles' law, volume of a fixed mass of gas is directly proportional to temperature. V by T is equal to a constant at constant pressure. That is, whenever the volume increases, temperature also increases. When temperature at 0 degrees Celsius, the volume of the gas meet at the graph. When the graph is extrapolated at a negative direction, it meet at a negative temperature of minus 273 degrees Celsius. At this temperature, the volume of the gas is theoretically becomes 0. It is the temperature at which the volume of the gas is theoretically becomes 0. It is called absolute scale of temperature. The last headline indicates the values of R. What is R? R is called the universal gas constant, and the values of R at different units are given in the chart.